Yeah. Hello, ladies and gentlemen. Thank you for being here. My name is Marcel Corneille from EMCEL, and I want to tell you about our solution in the field of hydrogen quality measurement and according analytics. So maybe to introduce EMCEL a little bit, to give you an idea what we are doing, who you're seeing here talking to you. EMCEL is an engineering company. We are focused on fuel cells, hydrogen and electric mobility in general. We are based in Cologne in Germany and more than 10 years in the market. So what we do, our focus, we have three focuses. One for today, most important subject is the hydrogen quality measurement and according analytics we develop together with partners and implement. We are also working on hydrogen infrastructure, power to gas solutions, doing feasibility studies, product developments together with our customers, for our customers. We're working in the field of regulations, codes and standards, safety and certification process. This is what we do, but I'm not talking about today. Third thing we do is we are busy in the electric public transport system or environment. We advise public transport companies, politics, people in the cities about the transition from a diesel fleet to electric bus fleet, whatever electric means, like battery buses, fuel cell driven buses, trolley buses, how to do the transition from these to from diesel technologies to the electric driven technologies to be locally environmental friendly, pollution free. Sorry. To focus on the H2 quality measurement, what we do is we doing consultancy work to make people understand what hydrogen quality means, especially to their certain application, to their hydrogen generation system or environment. For that means hydrogen production as well as hydrogen customers, for the customers to look at the impurities that could be consisting their hydrogen that they buy or import or use in their products. We also develop measurement equipment, hardware, together with partners, and what we see as necessary, especially in this now growing market, we see hydrogen measurement as a service. That's something we provide because this measurement equipment is very expensive, and usually while you're running your measurement campaigns, your hydrogen want to know about your hydrogen quality, it's not necessarily important that you own this equipment, that you use this equipment for many years, but to run campaigns, for example, certain weeks in a year or every once in a while. So this is equipment we could provide to you. This is just as a background to understand what we are doing and talk about in the next few minutes. When we talk about hydrogen, we need to ask why do we want to know about the quality? And especially from our opinion, especially now that we are in this growing market of the hydrogen industry, of the energy transition, of the sector coupling, we need to make sure that we use hydrogen of a certain quality and a certain purity to be reliable, to make sure the hydrogen or your application, your fuel cell, for example, is not failing because of impurities in the hydrogen. And these sources could be from any kind of hydrogen you could think of. So just to name the renewable sources, that would be electrolyzers running with electricity, renewable electricity like wind and solar power. That also means steam reforming of biogas, for example, or hydrogen from byproduct from industries, and of course biomass, wood chips, sewage sludge, and those kind of things. And these processes can be quite different from each other. Just as an example, we see here the process of a hydrogen refueling station, but please feel free to see your process as an alternative here. So we start with the hydrogen generation. We truck the hydrogen, in this case, to a fueling station, fill the hydrogen storage near the fueling station. We compress the hydrogen up to 700 bar or to even almost 1000 bar for the fueling process in the hydrogen passenger car sector. We cool the hydrogen to be able to fill the hydrogen in a few minutes to any hydrogen-driven car. So you see there are many steps in between this process where impurities can be added to the hydrogen. They can come also from a step before while you produce the hydrogen, like sulfur content of any natural gas, for example, or biogas. Or you have, while you compress the hydrogen, for example, on these several stages, you could have oils or fat or fluids from the compressors be transferred to your hydrogen. And these, of course, are all substances you don't want to find in your hydrogen. What we then do is, with our system or application, we draw samples from any part of any position. We could draw samples in any position of the production process, and which is just a T fitting, for example, and we just drew gas samples from the process. We sometimes need to control the pressure a little bit and then run the hydrogen through our measurement devices. And the one particular I want to talk about is the IMS, the Ion Mobility Spectrometer, which is placed in an outdoor cabinet with several other components, data communication systems, and this cabinet can be stored on any site you want to measure. So maybe to jump back, so this outdoor cabinet can consist of many or different modules. And as these, for example, are a certain or very popular, at the moment, popular list of impurities, which is written down or specified for mobile applications. According as well, you find international standards like SAE, for example, the 2719, or the ISO standard, and also the European version of this document would be the 1724. So these impurities are specified here. Unfortunately, no hardware, no measurement equipment today can measure all these substances. So our solution is, we built in our outdoor cabinet, we built different modules that could measure certain impurities or special parts of these impurities. And today I want to talk about the most harmful impurities that can be found in hydrogen, or that are found or that are listed in these standard. So these are the ones like sulfur, like hydraulic oils, like hydrocarbons, complex hydrocarbons that will be in pretty short time will be very fatal for the fuel cell. You have other impurities that rather would dilute the hydrogen, wouldn't temporarily or just temporarily harm the fuel cell, but these are the most harmful, and they would irreversibly harm the fuel cell and shorten the lifetime of your fuel cell. How does this module, this system work? Sorry. It's very easy, very simple system, and so we have the hydrogen or the gas flow injected here that will be ionized by an electric or a tritium source, and then will be propelled into the measurement chamber and will be detected from a collector and processed from the amplifier to draw these solutions and give you the peaks and the measurement details of your substance. There will be also the counterflow, airflow against the electric field that will be hampered, so to give you even more detailed view on your impurities in your gas flow. And since this is a very simple and easy setup, the gas flow you need, the hydrogen gas flow you need is very low, so you don't waste all your hydrogen that you want to use in your car, for example, to be measured. It just pulls a few cubic centimeters of hydrogen gas that's analyzed, and therefore it's quick. So what we recommend is to do online measurement. Don't draw samples of your hydrogen in a container. Bring this container in a laboratory and do, as you see here, certain samples, single samples, isolated samples. We recommend to do online measurement because it gives you a more detailed view on your process. You will understand your process even better and could improve your filters, for example, your own production process. So what we see here is the concentration and a time step, which is in this case a few days, 60 days. And what people sometimes like to think is that impurity in a hydrogen gas flow is something very constant. But what we see from our measurement, it's not. These are living processes. So the impurities are fluctuating. They go up and down. Certain concentrations appear only in the morning or when certain process parameters are not in a good setup for your purity. So you have different fluctuating processes, and that's a big advantage of the online measurement. You see all these fluctuations during the day. If you draw samples in a tank and bring this tank to an analysis laboratory, for example, you could be lucky and just hit your peak, for example, the impurity, but you also could be unlucky and just hit a space where at this particular moment when you're drawing your sample, which is when there is no impurity at all. So you think you're clean, you're fine, which makes you happy, of course, at the first moment, but on the long-term perspective, you have the big disadvantage that you don't know what's going on in your process. So with this technology, with our technology, you could draw samples up to every 5 minutes, even quicker if you want to. But so far, we set the system up in this way because we think that would be sufficient for the sample rate. What can you do with this measurement system, with the IMS, with our hardware? You have the opportunity to use, which reflects in the costs later on that you need to spend for these analytics. You have 3 different levels of detection. So the first one is to detect the hydrogen itself or the impurity itself. So you can easily say, is my hydrogen clean or is it not, according to all the impurities we see with the IMS. You could determine certain impurities, certain substances. You could tell this is, for example, a certain sulfur impurity or contamination. And what you could also do in a third step is you could quantify the impurity, for example, for this particular sulfur content. You could tell how many ppm or ppb of your impurity is in the system, according to the different regulations, codes and standards. But you, of course, could also specify your own limits for these particular impurities. So how does it look in real time or in real life? This is to show you. This is a sample for hydrogen, for pure hydrogen of the quality 6.0, so pretty clean hydrogen. And you see in this sheet here, there's nothing to see. It's just a plain white piece of measurement diagram. So this is as a reference, could be your clean hydrogen. And then on the first step, just to detect, just to decide, is my hydrogen clean or not, you could see different patterns here, which tells you there are impurities, there are certain impurities, even though you don't look for a specific one. For example, you could tell there are impurities. For example, you could look for a particular sulfur or impurity, which would be placed here, for example. And as you see, you don't, you can't. This is pure. This is would be clean hydrogen, but you see also, even though you're not looking for your particular impurity, there is something. So you can be alerted firsthand. What you then can do as a first step is to determine the particular impurities and look whether it's, for example, NH3 or whatever kind of other impurity, maybe some complex oil substances from your compressor, for example, and that gives you a cheap and quick way to understand the quality of your hydrogen. And as a third step, you of course can quantify the amount of hydrogen, the amount of impurity that's in your system with the multi-point calibration. That's something we do for you, and but you also could do for yourself if you want to, and then go down to the ppm or lower ppb content of your hydrogen and determine what your impurities are looking like. That also comes since we suggest to place these fields next to your hydrogen application, to your production process. In an outdoor atmosphere, in the equipment, you don't want to go there. This is, of course, today's technology. You could check your impurities via web application on your computer or on your mobile phone. You could, the system is able to send you messages as soon as certain parameters in the system are or limits are reached. So like alarms and concentrations, you could control the system, switch it on, switch it off, do reference tests with the system all via your mobile phone or through your computer in your office. So to summarize it, the hydrogen system is to measure hydrogen impurities assembled to your needs. So you just use the module that you need for your impurities, and you could measure multiple impurities, for example, according to the standards that represent the mobile applications that we see these days, like cars and buses, trucks, but also you could detect unknown impurities and, of course, specify your own impurities you're looking at. This is highly sensitive, this equipment, so you could measure down to the lower ppb range, which would be the thousandth part of ppm. You have the online capability to measure online in a frequency of every 5 minutes or even faster if required for your particular process. You have, of course, the web application where you could control the system, give you alarm messages, and the whole system is pretty robust. You could use it indoor but also outdoor. You run your system in snow and rain and weather wherever you produce your hydrogen in your production plant. And thank you, ladies and gentlemen, for your attention. And if you like, please visit us at our booth over there on C46. Thank you very much.
Thank you very much, Marcel Corneille. Are there any questions from the audience? Yes.
Thanks for your presentation. We are a company use masonry forming on the board in the vehicle. So do you think with huge investigation, is that possible to make your measurement in the vehicle possible?
Yeah, we could do that. All we need is 220 volts or a particular energy source. So I think in your car in a test setup, we should be able to draw current for your from the 12 volt system in your car and bring it to invert it to 220 volts, and we could run your system in the car. Yeah.
Thank you very much. If you have further questions or you want to discuss the topics further, please go to their booth on the site. He mentioned it before. It's C46. Thank you very much again.
Thank you.